quadratic equations. Now we've got these 5 quadratic equations to do. This one's a problem. Okay, so you can pause the video and have a go at them. The first one is an interesting one because I think when I was a young teacher I forgot to do this with my students, and a lot of them expanded the brackets out and used the quadratic formula and wasted a lot of time. In the factored form it's very simple because either 2x minus 3 will be equal to 0 or x plus 4 would equal 0. So 2x must equal 3, x equals 3 over 2 or 1.5. Here x equals minus 4. As simple as that. Right, moving on here, this time we're going to factorise it, and it goes back to what we were doing before. So what two numbers will multiply together to give me negative 10 and add up to give me 3? Well, clearly that's going to be 5 and minus 2, isn't it? Yep. What's the signs there? 5 and minus 2, that's right, isn't it? Yep. Okay, so what we'll do here, I'm going to do the shortcut way. I'm going to write this 2x all over 2, and we'll put in a 5 there and a minus 2 there equals 0. So straight away I can see that 2x plus 5 equals 0, so x equals minus 5 over 2 or minus 2.5. And here 2x minus 2 equals 0, that means x must equal 1 as your solution. So it's quite neat, that little method for solving a quadratic. Right, this one here, now this is again same sort of thing. Do not expand and use the quadratic formula. No point in doing that whatsoever. What we do here is simply take the square root of both sides. So x minus 5 equals plus or minus the square root of 6. So x equals, take the 5 across, 5 plus or minus square root of 6. And it's okay to leave it in that form. Or if you want to write x equals 5 plus root 6 or x equals 5 minus root 6. Just be careful, sometimes they want you to give an approximation, so just watch the question for that. That's the exact form. Right, over here, show that there are no real solutions to this. Well, first of all, what we'll do, we'll simplify this, and we'll multiply it throughout by x. So that gives me x squared equals x minus 1. So x squared minus x plus 1 equals 0. Now this time, I'm going to use the quadratic formula. So what we'll do here, I'll say that x equals, the coefficient here is going to be minus 1, so it'll be 1 plus or minus the square root of b squared, which is 1 minus 4 times 1 times 1, all over 2 times 1. Now that's going to be 1 plus or minus the square root of, this gives me negative 3. So you see, these are actually complex solutions, what they do in their high-level courses, but there's no real solution to this. Now you could have bypassed that simply by going to here and looking at what's called the discriminant. B squared minus 4ac, and you would have got the negative 3, and therefore you would have said straight away no real solutions rather than going through all this business here. All right, little problem. You know, the area of this section here is 80, and we know this length is 21, and we know this is a square. So how do we work out length of CD? Well, I'm going to let this CD equal y. Right? So that's y. Okay. So this this distance here will be also y on this side, and of course this is a square. This will be y. So this area here that of the square is simply y squared. So we know that y squared, the area of the square, plus the area of this one, which is 80, must equal the area of the total rectangle, which is 21 times y, or 21y. So we've got a nice little one to solve. So we get y squared minus 21y plus 80, equals 0. So what two numbers multiply together to give me 80 and add together to give me minus 21. And I do believe that's 5 and 16. Minus 5 minus 16, isn't it? Yeah, minus 5 minus 16. So this becomes y minus 5 and y minus 16 equals 0. Therefore, y could be equal to 5 or y could be equal to 16. So either of those will work. Make that 5 or 16. That will give you the same result. And you can check that out yourself. Okay, that's done.